In this video, we are going to learn how to adjust the pneumatic lubricator's drip rate. When we're done with this video, we will understand the basic principles of how the pneumatic lubricator works, how to adjust the drip rate. We're going to set it at 1 drip per 60 seconds, and we are going to learn a little bit about flow controls and how they affect the lubricator in its function. The type of lubricator we are reviewing today is a metered venturi or drop type lubricator. A venturi is a device that uses the pressure drop across a restricted fluid passage to reduce the fluid pressure below the input pressure, thereby creating a pressure difference. The pressure difference pushes oil through a siphon tube into the air that flows through the lubricator and to the components downstream. Knowing that information, let's take a look at the diagram and follow the airflow and the oil as it travels through the lubricator. The air enters at the air entry point right here. Traveling through this, it first meets the venturi. The venturi creates the pressure drop that we were talking about, which creates a low pressure effect that draws oil from the bowl through the siphon tube into the sight, dome, and oil regulator knob. Once the oil builds up enough on the sight dome, the oil drops, falls back into the main air supply, and travels downstream to the air out and to the actuators. Now that we've looked at the internal components and their basic operation, we're going to start with the outside of the lubricator. Starting on the top view, we have our air outlet, our air inlet, and you can mark the inlet and the outlet. Look for an arrow. See how we have an arrow right here? The arrow indicates the direction of flow. On the very top, we have our sight dome and adjustment knob. So this thing right here pulls double duty. It's the sight knob, and the other one is it actually helps us adjust the drip rate of the lubricator. Then we have our scale markings. So the scale markings are there to help aid in determining where the set factor is on the lubricator. The last thing that we're going to cover is actually the fill point. This is our fill point for it. This unscrews and allows for you to add oil to the lubricator. Here's the front view of our lubricator. There are several things to note. First is the body. This is the physical body of the lubricator. This is our bowl. The bowl has an oil maximum and an oil minimum level. So we want to keep the oil in between these two levels, and we do that with the sight glass here. So here's our sight glass. So our oil on this one is right there, so it's full and good to go. Down here we have the drain. So once we get the oil all the way down, we usually will drain it because it'll capture some impurities and things like that. So we can drain the oil out right here. And then we would refill it again from the fill point up at the top that we looked at earlier. In this image, we have both flow controls and our lubricator. The flow controls, seen here, adjust how much flow and the flow rate being provided to the lubricator and to the actuator. It is important to note that anytime a flow control valve is adjusted, the lubricator flow rate must also be adjusted. So we have mentioned briefly the flow control valve, but to really fully understand how it works, we have disconnected the main supply line from our lubricator and have plugged it into a pneumatic motor. And we are going to turn the air on and have the motor run. And we're going to demonstrate how we can use the flow control valve to manipulate the motor. So right now we can see that the motor is spinning fairly slow. We can see the physical tape that's on the shaft as it's spinning. So we're going to turn this, we can turn it going one way or the other. So turning it counterclockwise, the motor speeds up. Turning it clockwise slows the motor down. Now we're going to set the physical drip rate or supply feed of our lubricator. In this exercise, we're going to set it at 1 drip per minute, and we have already set our regulator to 22 psi. We're going to turn our air supply on while maintaining positive control of our pneumatic hose to make sure that it doesn't whip or create a hazard for anybody in the area. Remembering that our sight dome also doubles as our adjustment knob, we need to note that turning the knob all the way clockwise turns the oil flow off, while turning the knob counterclockwise increases the drip rate of the oil. With our air supply on and free flowing, we're now going to turn the oil supply on. We're going to do that by turning the adjustment knob to the on position. It's all the way in the off position right now, so I'm going to take it and I'm going to physically rotate it and put it in the on position. And we're going to watch the droplet. There was our droplet. At this point, we start our stopwatch and we wait for the next droplet to stop, and we can adjust accordingly. As we can see, that droplet was happening way faster than 1 drop per minute, so we can turn the adjustment back down, and we'll make small adjustments until we reach that 1 drop per minute requirement. It's important to note that the drop rate is extremely critical for multiple reasons. First reason is air quality. Any excess oil that is traveling through the system and is exhausted can create a health hazard for the workers. So we don't want to have more exhausted oil expelled than needed. Additionally, it will put more lubrication in the components than is necessary, which can cause gummed up oily messes that can create slip, trip, and fall hazards.